Hi guys, welcome back. We got a little bit of notes today. It's going to be 2 slides of notes. It's going to be on 2 new topics. The first one is the one that you're seeing right over here called incomplete dominance. And then the next one is going to be about codominance. And that's it, just 2 slides of notes. Uh, the good news about this sort of stuff is that it's the same process you've been used to from hopefully middle school and the last lesson as well, where you're going to do a Punnett square. The only thing that's changing is what's in it. So let's take a look. Write down your notes, that way you can reference it when you're working on the homework. Incomplete dominance is when both the recessive, so in this case the white one, and the dominant, in this case the red one, phenotypes, which is how it looks, so white, red, are shown in a heterozygous individual. See how hetero means different, and these are all different types of letters, in a fully blended form. So the thing that's different about this from last time when we're learning about it is normally if you mix the dominant color with the recessive color and you had a heterozygote, the one that has both types of letters, these would all be red because they would all show the dominant color because they had at least one R. But with incomplete dominance, you see how it's blended? You see how red and white blend to form pink? Just kind of like with paint. You have some red, add a little bit of white, and you mix it up, and it'll turn pink in color. So that's what I mean by incomplete dominance. Now, there's another form of this which follows the same rules, but it's not going to be a fully blended form like this, and that is codominance. So that's when the recessive and dominant phenotypes, so we got the dominant one here, the darker colored, and the recessive one over here, are shown in a heterozygous individual. These are all heterozygous because they have different letters, in a splotchy sort of unblended form. Notice how this cow was white, this cow was brown, but now instead of being like kind of like with this previous example, how it was a shade in between the red and the pink, the red and the white to form pink, this doesn't really fully blend. Instead, it's splotchy. Like you've seen cows like this, hopefully, either in real life or in pictures, where they have spots. And that's what you're seeing here. All right. So really the main difference between incomplete dominance and codominance is how the coloration is. What does it look like? Is it a fully blended form like this, where you just combine the two to form a brand new full color? Or do they just take parts of each? All right. So I have some questions for our opener today, and let's see how you do. This one, that cat. I want to know, is that incomplete dominance like this, or is it codominance like that? Take a second, think about it, pause the video if you have to. All right, the right answer here is this cat is showing codominance. It's showing bits of different parts, all right? It has some white and some black and some brown, all right? So it is showing codominance. All right, this is not real. This isn't a real example. These aren't how platypuses are made, but just for a funny joke, is this incomplete dominance or is it codominance? Take a minute, think about it. If you said that this is incomplete dominance, you would be correct because you see how it's kind of naturally blending the different things that are in here. You have the colors are kind of blended to form this lighter shade of brown. The different parts are blended. So this would be an example of incomplete dominance. Again, not a real example, just for fun. This, again, not a real example, just for fun. But is this incomplete dominance or codominance? I'm not going to flash back this time. Look back at your notes. If you said codominance, you would be right because it's showing parts of each. It's not a full blend. It's not like a gray throughout each one of these bears. It is parts of each. So it's going to be codominance where you're showing parts of each one. Okay. This one, incomplete dominance or codominance. By the way, whenever you see this X, it means this flower mated with that flower. All right. So like mom, dad, or vice versa. Is that incomplete dominance or codominance? This is going to be incomplete dominance because it is kind of like a blend or a mixture between the two. We have the tall one and the short one forming the medium one. It's kind of like the halfway in between, just kind of like with these flowers, pink is halfway between white and red. All right, last one. Incomplete dominance or codominance? All right, so with this one, I actually tried to trick you. This is neither. This is just normal or regular dominance, because what you're seeing is whenever it has a capital A, it's showing the dominant phenotype. It's only when they have two lowercase a's, the recessive one, that they're showing the recessive phenotype. So this is neither. It's not incomplete dominance. It's not codominance. It's just regular dominance like you learned about last week. All right. So let me show you the homework for today, and I'll even do a problem or two with you. All right. So this is going to be incomplete dominance on this page, and on the next page, it's going to be codominance. So let's go through and take a look at this. It says SpongeBob loves growing flowers for his pal Sandy. Her favorite flowers, puffkins, are found in red, blue, and purple. Use the information provided and your knowledge of incomplete dominance to complete each section below. Write the correct genotype for each color if R represents red gene and B represents blue gene. So remember, when we're looking at these examples over here, there was no lowercase letters when we're talking about codominance or incomplete dominance. These are just showing their own sort of dominance. There are no recessive parts to this. All right, so over here, when I go to write it out for red, I'm just going to write RR for red. All right. And then I am going to write for blue, B for blue, because you always have to have two alleles because you get one from your mom and one from your dad, and that's meiosis. For purple, remember, purple's a mixture of red and blue if you ever take an art class. So you're going to write RB because purple is a mixture of R for red and B for blue. Says, what would happen if SpongeBob crossed a puffkin with red flowers with a puffkin for blue flowers? Fill out the Punnett square and determine the chances of each flower color. So we're going to wind up having in here, looks like I can't quite write where I want to write, but right here is going to be red. So it's going to be big R, big R. So let me go ahead and put a big R in each one of these boxes because I knew that one of the flowers is going to be red. So it's going to be big R, big R. And then the other flower, it says, is going to be blue. So it's going to be big B over here. Otherwise, it wouldn't be blue because blue is big B, R is big R, and purple is RB. All right. So big B, big B, because there would be B's here and R's over here. So give the genotypes and percentages for the offspring. So you would write for this RB, you would write genotype RB 100%, and you would say phenotype is going to be purple because RB is purple. All these guys are purple, and it's going to show up there 100% of the time. How many of the plants would have red flowers? Well, how many? None. 0%. How many plants would have purple flowers? How many? 100%. So you'd write down 100%. How many plants would have blue flowers? None of them. 0. So just like that, and you continue on the line. So I did the first 2 problems with you. You got 2 more to go on your own on this page. Over here, let's do the codominance practice. SpongeBob and his pal Patrick love to go jellyfishing at jellyfish fields. The fields are home to a special type of blue and yellow spotted jellyfish known as a goober, and only really great jellyfishermen are lucky enough to catch some on every trip. Many of the jellyfish are yellow, which are YY, or B, which are blue, or blue, which are BB. But some end up blue and yellow spotted as a result of codominance, what we just learned about. Use this information to help you complete each section below. What would happen if SpongeBob and Patrick crossed two goobers, cross meaning mated these two goobers together, or blue/yellow spotted jellyfish? Complete the Punnett square. So that means that the mom is going to be a goober and the dad is going to be a goober. And a goober, it said before, is a blue and yellow spotted fish. So it's going to have both a Y and a B. All right. So let's say the Y is going to be here and the B is going to be here. So it's going to look like this. It's going to be Y, Y, B, B, because the Y is going to be here going down. B is going to be here going down. The other parent is also a goober. So it's going to be Y, B again. So it's going to be Y going over like that. And then B going over like that. Now, I'm kind of glad this happened because this happens sometimes. This is actually the same thing as this. It's just the letters are reversed. It's going to have the same phenotype and even the same genotype. So if it makes you happy, you can just reverse it like that. And you'll know that's a combination of blue and yellow. All right. So it gives the fox possible genotypes and percentages for the offspring. Did I screw the previous question up? Oh, I didn't even need to do the phenotypes. Sorry about that. I was reading too fast. All right. So possible genotypes. Okay. It's going to be YY. And how often is that going to show up, guys? It's going to be there 25% of the time because it's in 1 out of the 4 total squares. The other genotype is going to be BY. How often is that there? As a percentage, it's going to be there 50% of the time because it's in 2 out of the 4 total squares. Okay. Last one is BB. It's going to be there 25% of the time because it's only in 1 out of the 4 squares. 1 divided by 4 is 25%. All right. What percentage of the offspring are going to be yellow? Well, yellow is YY. So what percentage? Same as the YY genotype. It's going to be 25. What percentage is going to be blue? Blue is BB. B for blue. So that's going to be also 25. What percentage is going to be goobers, which is blue and yellow spotted? Well, it's the combination of both blue and yellow. B for blue, Y for yellow. It's going to be there 50% of the time. Okay? So you see, hopefully it's not all that hard and all that bad. I want to show you one last thing before we're done. I saw this before and I thought this was helpful. If you're having a hard time with incomplete dominance or codominance. If you cross a red and a white flower and it looks like this, that's incomplete dominance. It's a blend. Also, if you cross a red and white flower and it looks like this is codominance. See how it's splotchy? It's not a full blend like it was with incomplete dominance. Hopefully that might make things a little bit easier. So I wanted to share that with you before I go. If you have any questions, please email me and I'll definitely help you out. Have a good rest of your day and good luck.